Hello everybody. I'm going to take you today through the tutorial to download and run the Task 2 seed, which should help you figure out how you're going to integrate the things that you want to do with the existing seeds that we have. And it ties a little bit with what Task 1 did and how we're going to relate Task 1 to Task 2. So let's begin by starting here in my root directory of my home. I'm going to make a new directory following the tutorial here. I'm just going to copy and paste straight out of here. Copy to paste, by the way, if you haven't figured that out yet, Control-Shift-V is the way that you can paste, or I think you can actually just right-click and paste here. Okay, so now I'm in my Cat Vehicle Challenge Task 2 workspace. I've created a new workspace, and I'm going to initialize this workspace, catkin init workspace. So this creates my CMake lists here, and now I'm ready to install the packages that we need. So again, I'm just going to come here. We're installing three things. We're installing the Cat Vehicle Simulator. We're installing the Obstacle Stopper, which is something that we need as an external package. It's generated from an internal Simulink model, and so we generate an external package for that. And then we also have the seed here for Cat Vehicle Challenge Task 2. So I'm going to come here and grab all three of these, copy, and then paste over here. And it'll do them one by one. I may have to press return at the end. Nope, looks like we got them all. Oh, yep, I will. So I had to still press return at the end of that other so that it would download it. And you can see now we have the Cat Vehicle, CV Challenge Task 2, and Obstacle Stopper. We have all three of these downloaded. So interestingly, because we changed some things in the simulator after you ran Task 1, the Task 1 seed that you had from before won't run with the new simulator. So we made some mild changes and actually shipped an updated version of Task 1 inside of Task 2 here. So it's a little strange to think about, but why don't I just demonstrate to you what we did. And there are good reasons why we did this. So if you want to know about those good reasons, just fire up a question on the forum and we'll help you. So now that I'm here in my workspace, the only thing I should see here is my source. And I'm going to run catkin make, which will compile the entire release. It compiles all the software that we have for the Cat Vehicle, and it sets up the libraries, produces all the runtime paths that we need for when we're going to be putting things into our path, so that in runtime we'll be able to find all the things that we need to have in order to run everything. So we should have everything all set here. I'm going to test it by sourcing devel/setup.bash. And then exactly what we see here. So we're going to run a launch file, ROS launch, CV challenge task 2. So we're now in task 2 land, and Cat Vehicle custom launch. So this launch file is one that we copied from an existing Cat Vehicle repository, which allows us to specify custom world files. And the world file that I want to specify, which we can specify here, := world 1.world. This will select an existing gazebo world and use initial condition information and all other kinds of information from elsewhere. You'll recognize this screen flying by as having a lot of detail that we're not really going to be using. So let me now step here and run gz client, gz client, so that we can see in gazebo what the world looks like. And my machine looks like it's not cooperating today with gazebo. We might just have to, oh, here we are. We have a bunch of boxes sitting around in this world. It's not that interesting. And you can see that the laser sensor is touching these boxes in various different places, which is kind of nice. These are obstacles that we'd like to be able to detect. And so let's look and see what these appear to be inside of RViz. I'm going to make a new tab here. Source devel setup.bash. You have to remember to do this every time you make a new tab. ROS run RViz. If you haven't run the other tutorials that integrate the Cat Vehicle with RViz, you may not have a visualization file that has various sensors available and doing interesting things. I think I do, but RViz also seems like it's about to be really unhappy with me. Thank you. All right, let's try this one more time. Here we are. So we can see sort of the same kinds of things. We see a bunch of things that look a little bit like squares here. but not exactly. Like we can't see that it's a square, we just see this angle and this angle here. And that's kind of what makes the challenge a little bit interesting. We're inferring from the kinds of obstacles we have, that we think we have, and using data to figure out whether that really matches the kind of obstacles that we see. So one thing that I want to show you is that each one of these points that's being returned from the various different kinds of sensors gives you information, for example, about how, I'm just scrolling around here to get a similar kind of view. So we see information about how high it is off the ground, maybe what the angle is from the current sensor. We can project that using TF transforms into the orientation and position of the vehicle. And those are the data that you get back if you're subscribing to this topic. It tells you, oh, at this particular angle, I got something at this particular distance. And all of the depth maps that you see here, you're interpreting as point cloud data or laser scan data using ROS kinds of APIs. So you'll be subscribing to specific messages and then doing things with those messages to figure out what it is that you exactly want to do. But I want to show you now what you did in task 1. And I'm going to do that by returning to my command prompt. Control-Shift-T, make a new tab. Not forgetting that we always need to source devel setup.bash. And ROS run CV challenge task 2. And I want to rerun now task1.py. So this was a generic output of a polygon, and we have some time stamp that's moving around in time and telling us where the polygon should be. I want to take that polygon and show it to you in RViz at the same time that we see all of these other obstacles that are really coming from the sensors. I want to show you the kinds of data that you produced. So by topic, I came here to, let me show you again, RViz, add, by topic, detections, polygon. Okay. We should now see a polygon sort of moving around the cat vehicle here. It's green in color. Let me see if I can make it a different color so that it shows up a little bit better. Instead of making it green, let's make it be this hot pink. There we are. And again, the data that came from task1.py was just to show you what the message type is that we expect to have as a detection. And the detection that we see here is just this square, and it's running open loop. It just has data from the clock, and it decides where to move things with just the clock information. What does it mean? It means that I'd like for you to replace the kinds of things that we see here with detections. So I'd like to see a detection of, say, this obstacle and this obstacle. I don't think they're connected to one another because we don't have any points that actually connect them. And you can infer what you want to infer about what the rest of the shape is that you can't see. So you can decide, well, maybe this is a triangle. I'm just going to connect that point to this point, and I'm going to infer that these arrays, because they're all kind of close to each other, that these arrays give me an obstacle that's of this shape. And so I'm going to output now a polygon, except instead of having 4 points, it's going to have 1, 2, 3 points, and then I'm going to allow those 3 points to come back to one another. This is what task 2 means to you. You get to choose the sensors that you want to use to figure out exactly what these various obstacles need to be. And the sensors that you have available to you are the ones that are available in the cat vehicle. And so this is it. This is task 2. Take the randomized, semi-randomized output that we see coming here, and instead extract data from the sensors to provide squares, triangles, circles, polygons of 30 points or 5 points, however it is that you want to do it. And it's up to you to decide where to go from here and how it is that you want to do it. So keep your eyes peeled on the various bits of information that are flowing from the tutorials on the CPS VO, and please head over to the forum if you'd like to ask us any questions. And good luck.